pleasure to welcome you to the presentation of theme number 7, Smart Cart. As you can see, in the last 10 years, there has been a tremendous increase in the size and number of shopping malls and supermarkets. So, especially in context of India, this is very relevant nowadays because with the FDI regulations coming in, you can expect a lot more supermarkets and giants like Walmart to turn up in India. And as a result, the consumer base has shifted from normal markets to the supermarkets, owing to certain advantages like air conditioning, centralized system, and a wide variety of products. But in spite of these advantages, only because of the huge size and the large variety of products, it may be a bit difficult to find what you need in a supermarket. That's sometimes pretty confusing, and I'm sure it has happened to each one of us. And the problem is even more severe for elderly people and people from foreign countries who do not understand the local language. So we need an innovative solution, and therefore we present Smart Cart, a unique shopping experience. Next slide. So if you're lost while shopping, don't worry anymore because Smart Cart is here. As the name suggests, Smart Cart is a smart shopping cart or a modified shopping trolley which will guide the customers around the store. The customers can just enter what product they want on a drop-down menu on a touch screen here, and it will guide it to the particular shelf he wants to go. So moving on. So what are the main features of this innovative solution that is Smart Cart? First of all, it's intelligent. That is, it helps the customer navigate through the store, and it does it in such a way that he follows the shortest path to a particular direction so that he doesn't have to walk more than it's needed. And then it has a very user-friendly touchscreen. Even people who are not tech savvy and do not have much experience with technology can use it. So even for naive users, it's very easy to use. And if you want to roam around the mall, because the purpose of the mall is just that, to roam around and see for products that you may not need at that point of time, but you will certainly need the view wide. So there's also control for manual. There's also manual control option, so that you will stop the navigation and just control it yourself and roam around the mall. So next slide. So I think at this point a video which is illustrating the actual functioning of the Smart Cart will give you a good idea about the product. Start the video here. So this is the LCD screen where the user will input the product he wants, and these two on the sides are sharp sensors which are used in parking sensors. They detect the shelves. And this is a sonar module which detects moving objects, and they have a larger range than the sharp sensor. And this is the RFID reader. The floor of the mall has RFID cards so that it can generate its position by reading those RFID cards through that RFID reader. See, it stops because that passes. That's because of the sonar. Then it's navigating through the mall, and the user actually manually controls it here, but because there is a shelf there, it stops suddenly because of the sharp sensor. So it's foolproof. So now the user has again put it into navigation mode, so it's going towards the billing counter, which is actually the destination which the user has typed in. And these are the RFID cards, which are very cheap and can be fitted all around the mall. Okay, thank you. Next slide please. Okay, so now we come to the mechanical design. I will let my colleague here explain the mechanical design.
As you can see from these views, the mechanical layout of a Smart Cart is not much different from the normal trolleys we have in shopping malls. But it has all the advanced features which we intend to propose. The main purpose of keeping it mechanically simple is that the users do not have any difficulty in handling these Smart Carts, because not all the customers have an experience with Smart Cart, so we have kept it as simple as we can. Now moving on to the next slide, we here mention the dimensions of our trolley. Now these dimensions have been taken keeping in mind both aesthetic as well as economic point of view. Now the height of the trolley is such that a person with average human height can use it successfully without any difficulty. Now moving forward, now in order to aid the mechanical movement of a trolley, we have a caster wheel which is right in front here, which helps in the easy rotation and movement of the trolley. We also have two wheels which are driven by two separate independent motors. Now these motors help the two wheels to have different velocities. They can have different velocities, which is very much required in many cases. Because, for example, in cornering, the inner wheels have to cover less distance as compared to outer wheels. So these two wheels have to have different velocities. So these two different independent motors help them to have different velocities and have a proper movement of the trolley in the whole mall. These are the specifications of motor which we have used for these two wheels. These specifications have been specifically taken because so that the cart is able to handle the maximum load at the possible velocity which we intend to move the trolley, because a person has to chase this trolley. So it has to move at a velocity so that the person can also move. So this torque has been designed with such a purpose. Moving forward, now I hand over the stage back to Rajat for
Okay, so now we come to the most important part of this, which helps in the navigation as well as the detection of objects, that is the sensors. The first sensor is of course the touch screen, where the user enters the data from a drop-down menu and it will guide to the particular shelf. And then next is the digital compass, because the geometry of all the malls may not be same. So once we enter a lane, the lane may be in the northern direction or northeast direction, so we also have to have a direction vector. So that is from a digital compass. And then we have sharp sensors. As I said before, they detect objects which are very close, like the parking sensors. And then the sonar module, which detects moving objects, and they have a slightly larger range. So as you know, a mall is a crowded place. There may be people and other trolleys moving there, so it will help in that way. And the RFID reader, actually the whole mall floor has several RFID cards placed at strategic intervals, at regular intervals. So basically the RFID reader at the bottom of this trolley will read the position and it will detect the position it is, and from that mapping it can generate the navigation graph from up to where it will go. So next slide please. So this is the LCD touchscreen. It's a pretty regular touchscreen, 3.2 resistive touch panel which fits perfectly on this, and it communicates through the UART to the master controller, which is below. So this is the compass module. It refreshes the data at a rate of 100 Hz and it uses the I2C protocol. And we actually check the direction of the compass with the magnetic north, and we use a proportional controller in order to fix the direction. Next, sharp sensors. As I said, they are the regular parking meter sensors, and it outputs an analog voltage which is proportional to the distance from the obstacle, so that we can stop then and there if the distance is very less. And it actually requires a ADC for interfacing with the microcontroller. So next one. And this is the sonar receiver. This is very important because of all the moving objects in the world, in the mall. Provides data at the rate of 4 Hz and outputs a pulse which is proportional to the distance of the obstacle. This actually has a detection range of about 5 cm to 3 meters. But whenever an object is between a 20 cm radius, we would like to stop this or decrease the velocity of this. So next. And this is the RFID reader, which is a pretty standard object. It's used in the reading the codes of all the objects, all the shopping goods. And this is actually very useful in creating the navigation graph of the mall. And we can employ a shortest path algorithm using these lanes, which will take us to the product in the least amount of time. Next. And for the slave controller, we use a Atmega 640 development board. This board is specifically chosen because it has a lot of peripherals, and we actually need a lot of UART and serial communication sensors, therefore we choose this board. And so now it's time for the most important thing, that is the demonstration. So I would like to welcome you, and he will show you how it operates.
So first I'll show you the various sensors, and then I'll operate. So as you can see, there are 2 sharp sensors here and 2 sharp sensors here. So these are used to avoid collision with the shells, these 2. Now we have 2 sonar modules here. So suppose this cart is moving in a mode and someone comes in front suddenly. So this cart should not collide with the person. So this sonar module detects the obstacle and stops immediately if the obstacle is nearer than 20 centimeters. Now then we have a compass module kept inside this box. That compass module is used to align the robot, this cart, to the lanes of the mall. So a basic algorithm for its movement goes like this: that board should not collide with the shelf and also follow the direction of the lane while avoiding other obstacles. Now we have this LCD touchscreen. We have various options here. First is the search product. This one is used to navigate to a certain product. Like you can see, there are various tabs put there. So if we want to go to a certain product, we can go there. Now this thing shows our location on the in the whole mall. Manual control allows us to manually control the cart. Settings has some settings. Now we have two buttons here: pause and play. Now suppose a person is a cart is navigating through the mall and a person receives a phone call. So he would like to stop the cart there and then resume its operation at a later stage. So he pauses the cart, and when he is done with his work, he can resume it. So now first let's show the manual control. It shows 4 buttons. So with this, a person can easily manually navigate. Now let's go to search product. Now it shows various categories. Now let's go to a category, say clothing. Let's go to men's clothing. Now it will confirm. As soon as I confirm, it has started. Sir Ashish, can you please come in? See.
Sir,
sensors are there.
Beneath this carpet.
beneath this carpet, so it's not even visible.
Okay.
It's very cheap.
And now
So you can see
he has come in front and the cart has
stop.
stopped. Now please move.
So it again starts.
So how he detects and then stops over there.
Yeah.
It is your sensor.
Yeah. What we have a map of whole of this mall programmed inside the microcontroller. So we have basically a connected graph of the whole mall. Now each node in that graph corresponds to a single RFID tag, and we have a database of RFID tags mapping it to a particular product or a particular node. And so as we start from there, what this sensor does is it follows the shells, keeps on detecting the RFIDs, and based on the current location, it decides the next direction.
So this is the thing which has been put into the continuous thing.
It has been put in whole
In regular
of the mall.
intervals, so that it is a non-weighted graph.
And then whenever it comes here and detects an ID, it moves there because it has to go to men's
And
section.
as you can see, it followed the best part possible.
So path planning is also done using breadth first search algorithm, which gives us the shortest path. So now let's move somewhere else. Say let's go to speakers here. Speaker. this cart moves only in lanes, following the Indian lane system. This has been done so as to avoid a deadlock. Like it can happen, two carts can come in front of each other and both may stop. So this follows the Indian lane system. It is aligned to the left so as to avoid a deadlock. Yeah. Master, can you
please remove the carpet. Remove the carpet. So these are the RFID tags. These cost only 40 rupees per piece to the maximum. So we can use
like 40 rupees per piece in retail.
Yeah.
And each RFID card costs around 10 rupees each.
Yeah.
If we purchase in wholesale, like 200 or 500 cards.
And you have kept the distance in such a way that even if it stops in between, it can sense, get guided by this.
Yeah. Outside world, that's the sharp sensor, sonar, RFID reader and compass which he demonstrated very clearly there, and that actually communicates the data to a microcontroller which is the Atmega, and the touch screen also has a controller through which the user feeds the data and it also goes to the microcontroller, so it decides where it has to go, and then they obviously control the motor drivers which controls the differential driver. So next slide. So this is the user interface as you saw there. So you can search for a product, find the current location so you don't get lost in the mall. That is one of the objectives as well. Then there's manual controls because the whole point of the mall is for users to see around the product. Now this will help them navigate. They may feel like they want to stop somewhere, end a phone call or take a look at another product. So that's why the manual control is there. And along with that there is the pause and play button so that you can stop anytime. And the settings can be changed like the brightness and all those regular things are there in the settings. So next slide. So navigation is a very important aspect. So there are three aspects to it. It finds the current location. It uses the BFS algorithm because we have placed it in regular intervals, so it's a non-weighted graph. So BFS suffices. And then it detects the obstacles and avoids them because of the sharp sensors and the sonar. So next slide please. And there's the RFID tag which helps in determining where it is and what graph it should follow, and the digital compass for the direction, because all malls may not be aligned in a perfect rectangular manner. So direction vector is also needed. So next slide. So as I said before, obstacle detection. So sharp sensors and sonar, that already covered. Next slide. So now what are the advantages of this? First of all, it's comfortable. The user doesn't get lost. And it follows the shortest path, so there is time saving. It doesn't have to search all around the mall. And in fact, Walmart complexes are very huge, so it's a time-taking procedure. And of course, it's interactive. You saw the touch screen there, and any naive user can use that. You don't need to be tech savvy for that. And for the mall, of course, they would, if they implement this, they would be looking for profit, right? So obviously, they would guarantee better service. More users would come to the mall because they would be attracted to this. And because of time saving and not being lost, so there will be increased sales. And as you know, human labor is very costly nowadays. In India it's cheap still, but in Western countries it's very costly. So it reduces manual labor as well. So there's automation in it. So this is the cost analysis. The LCD touchscreen which we brought was of 2000 rupees, Indian rupees. And the sonar module, we have 2 sonar modules for 500 rupees each. And the sharp sensors are pretty cheap, they are 4, and if you buy it in bulk it costs 1000 rupees for 4 of them. And then DC motor costs, there's the normal DC motors, 2 of them cost 300. So as you can see, the whole setup, excluding the cost of the trolley itself, because that will already be there, we will just have to make it, modify this for this system. So that will be 6100. And as I said that the RFID cards that are there, they're very cheap, 10 rupees per piece. So that sort of cost, and even this would be insignificant to a huge name like Walmart and that. So it's a good solution. So now, what can we develop in future from this idea? From this innovative idea, we can actually implement automatic billing in the smart card itself. We still haven't done that, but we can generally do. For example, in most of the malls nowadays, the billing is done through RFID tags itself. Each of the products has a RFID tag. So we can just give another sensor in the card so that the user can just bill it when he puts it in the card. And we can also prevent theft because whenever he goes out of the mall, there's also RFID sensor there. If it has not been billed, it will sound the alarm, and so there will be no long queues in front of the billing counter. Everything will be smooth. Then in a completely different context, this can be used for industrial robots as well, for following different paths and doing different operations where human involvement may be treacherous or dangerous. And then in medical applications, in many of the hospitals, like the nurses and the staffs in many of the cases understaffed, so they have to run around from room to room gathering equipments and all that. So patients in wheelchair can actually be guided in this way through the hospital, and also equipments can be transferred in this way through the hospital. So this is a very good use and it can prove to be life-saving. So next slide please. So okay, so if you're worried about losing your way in the shopping mall, I don't think that problem lies there anymore. So happy shopping. Thank you.
You have explained it very nicely, and the demonstration was also very good.
Thank you, sir.
Yeah, good. Thanks.
Okay, sir.